Probability, example 16. A disease has an incidence rate of 2.5%. So let's just take a moment and think what we will do with that. It says down here, let's assume the test is administered to 10,000 people, and we see that down here in the chart. Okay, so how many do we expect to have the disease? The incidence rate is 2.5%, so 2.5% of 10,000. So let's not forget to move our decimal 2 places to the left, times 10,000, and that gives us 250. So remember, we would put 250 here. So we expect 250 people to have the disease. And then how are we going to figure out how many people don't? Well, recall that all we did was just, if the total is 10,000, we just subtracted 10,000 minus how many people had the disease, and that would give us 9,750. So that's how many people don't have the disease. Okay, all of that just from a disease has an incidence rate of 2.5%. So let's read on. The false negative rate is 12%, meaning 12% of those who have the disease. Okay, so have the disease, let's use a red pen here. So have the disease, that would be 250 people, wouldn't it? So 12% of those who have the disease will test negative for the disease. So we are looking for a number that goes here, okay? So 12% of them test negative for the disease. That means, well, how many people? So 12% of 250, that's going to give us 30 people who test negative. Well, look, if I know that 250 people have the disease and 30 of them test negative, it will be not too hard to figure out how many people test positive. So that will be the 250 minus the 30, and that will give me 220 people. So I want to mention again that this box right here, okay, that's where we are going to put the false negatives, all right? Because you tested negative even though you had the disease, false negative. Okay, so now we have this part taken care of. Okay, and the false positive rate is 1%, meaning 1% of those who do not have the disease will test positive for that. So let's look at the people who do not have the disease. That's these in this row right here. Okay, so they don't have the disease, but they tested positive. So it makes sense that our false positive would be up here, wouldn't it? Okay, so let's look down here. The false positive rate is 1%. So of those people who do not have the disease, well, how many people don't have the disease? If we look at our chart, we said that was 9,750 people. Okay, it says 1% of them will test positive. Well, let's see how to find that. Again, we're going to move our decimal 2 places to the left. So 1% times the 9,750 gives us 97 5/10. Okay, so that's going to go right here. Again, another reminder that this right here is where our false positive goes. All right. right, so we could finish filling out this chart, which won't be so bad. If our total is 9,750, we just subtract 9,750 minus 97 and 5/10, and I get, oh, let's go ahead and put this back on black, 9,652 and 5/10. Now let's find our totals of the people who test positive. So 22 plus 97 and 5/10 gives us 317 and 5/10. 30 plus 9,652 and 5/10 gives us 9,682 and 5/10. Okay, I'm going to move this up a little bit so we can answer these final questions. Well, the main reason that the question was posed, we want to find the probability. It says compute the probability that a person who tests positive actually has a disease. So when they say that, we are actually looking for the probability that a person has a disease given they tested positive. So how many people tested positive for the disease? 317 and 5/10 people tested positive. Of those 317 and 5/10 people who test positive, how many will have the disease? Well, that was the 220. Therefore, the probability that the person had the disease given they tested positive, so let's look at our ratio first. 220 over 317.5. So let's go ahead and change that to percent. So we're going to need to multiply that by 100%. Let's round to the nearest tenth. So 69 and 3/10% of the people who test positive will have the disease. So this is a lot more accurate of a test than the other one we did in example 15.